Right.
Yeah, I'm
So
starting the
do
recording
James,
up
let me
here.
know. Do James, let me know when you integrate that. See if it works. Good. I think it should. That would be the issue, but yeah. See what happens.
With the conversation. Hold on, I'm trying to post something to our forum here because it does go into a key differentiator of what to excuse me, yeah, using the right tool for the right job, right? So let me actually post this and then we'll review. Do go on forum. I believe in you. Boom. Yeah. So the question is kind of this that is stemming from the conversation is when do we use BI tools? So by BI tools, I mean business intelligence dashboarding tools that exist from things like Tableau, Power BI, but also tools like QuickSight, Looker. I think those are kind of most of the big ones here. So a business intelligence tool has been around for a long time, at least 10, 15 years. I agree with everything kind of James and Karen were saying earlier that yeah, Tableau used to be really expensive and kind of still is. Power BI, Tableau used to dominate the market share though. That's why I can even find like a BI tool market share. Probably should pull this up from like 2015 because Tableau used to hold a majority of the market share. So this is before they got acquired by Tableau by Salesforce. Tableau was probably up around 40%. It was crazy. But then Salesforce acquired Tableau, made it super expensive, killed the like community around it. Tableau used to be very community driven. I was part of that community back in the day. Tableau would have things like I don't know, fitness Fridays or whatever it is, or motivation Monday, yeah, workout Wednesday. There we are.
I think you're muted. You're not. We're not.
Hashtag data fam things. But after their acquisition, they got. I'm not muted. Can you hear me?
Yeah, we hear you.
I can check my sound. Yeah, okay. Yeah, so after their acquisition from Salesforce, their culture kind of got destroyed a lot. I was really kind of bummed about that. But yeah, Microsoft, they saw the advantage and they kind of bundled in Power BI with everything to do with Office 365. I'm also just double check my mic's the right one. So yeah, now anyone that uses like Microsoft Office gets like installed with Power BI. So it really kind of made it a lot easier for users to start using it as a BI tool. And I suppose if you're in the Microsoft ecosystem, you may as well stick within a Microsoft BI. So yeah, the BI tool place, this is kind of where you have your drag and drop. Let me see if I can find just like a Power BI like interface. It's like drag and drop connected data, and then just using a few clicks, you can create really like awesome empowered like dashboards, right? That are interactive, that are live, connected to the internet, connected to your data sources, and a really quick and dirty, a really quick way to create interactive, enterprise-ready dashboards for communicative purposes. And from the data scientist, like that's great, right? You should be able to have some exposure to BI, but note that there is specific job postings out there around like SQL analyst, BI analysts, whose jobs are typically a lot less technical than data science. They may not know a whole lot about Python, but they can write SQL queries and they're really good at making really interactive dashboards. But where we're going in
Actually,
our club, yeah.
you actually touch on a good topic, I think, for people about as far as which ones have market share. I would add, if you're looking at, okay, should I learn this framework or this product or this tool, or should I learn that tool or framework? And one thing you can look at is the market share and think, okay, if I go first for the things with the greatest market share, maybe the greatest number of possible jobs where they would be looking for that skill set.
I,
Just this
I
is,
would I would agree with that, but to the extent that, like in my experience, that a lot of these tools are all super similar. If you know a
yeah,
Tableau or a
you
Power
know
BI,
one,
you can
yeah.
fumble your way around QuickSight or Looker.
That's why I'd say
And then
start
like
with the biggest market share, but then you can always easily adapt if needed.
gross, Click is a 10% market share. That's crazy. Anyway, I hate Click. That's an opinion, not a technical technical recommendation. But yeah, a couple of things that I would like just highlight on the BI side. BI tools, since they've been around for so long, they're really good for executive dashboarding, providing self-serve analytics, business reporting, your KPIs, and they're kind of driven again by this group of SQL analysts or business intelligence analysts. And the consumers of BI dashboards are going to be your executive level, your managers, your very non-technical stakeholders, right? Contrast that to kind of where we're going to be going here with, yeah, some weaknesses of BI tools. There's a few. So you have some limitations around flexibility, right? BI tools are going to be limited in what you can do because it is a drag and drop interface. So you get limited exposure to the data cleaning side or the data preparation side. You can't build complex workflows. And really, the most important part for us is that it's pretty difficult to integrate with machine learning. And I'll also go beyond that and say AI, agentic AI as well. Integrating machine learning predictions, inferences, or chat interfaces. Or if they do, it's very expensive. For example, Tableau now has a product called Ask Data, which does have some like agentic AI capabilities inside of it. But again, maybe as data scientists, we want to have full control over how a user talks to and interacts with agents, maybe the agents that we develop internally. So this kind of gets us into the idea of data applications, which got introduced in week six. In week six, we touched on Dash applications at the end of the course, but I would also recommend looking at tech at software such as Streamlit and another one called Gradio. So if you're taking notes, that's Streamlit, which is awesome. I use Streamlit all the time. It's really, really cool. And the other one is Gradio, which is another kind of this one specifically called a machine learning app, right? So just keep these kind of in the back of your mind as we talk about kind of where we're going in week six as we move into this kind of ecosystem of data apps. So what is a data app? How is it different than a regular BI dashboard, right? So with a data application, these frameworks are meant to be powered by data. Data and ML, right? Data science, advanced machine learning, AI, agentic AI, etc. So model interfaces, simulations, decision engines, custom UI logic. So again, like a common like use case on the sports side that I've seen. Let's do soccer or like yeah, global football. So maybe you have like a lineup and you can sub players in and out, and in real time you'll get a new update to the expected goals that you expect this lineup to score. Or maybe if I change the number of minutes, I think that Messi is only going to play 60 minutes today. Maybe I have a live machine learning model powering my application that says, given this change to your lineup and expected minutes, these are the expected goals that we expect your team to generate, right? So again, notice that it's a machine learning powered application. It's not just information consumption, which most BI dashboards are. So you'll see anything that's going to be more like scenario modeling, interfacing with machine learning predictions, etc. And I would even go again the step further beyond that now is going to go into kind of AI and agents. So again, I'm kind of pulling this off of Databricks, but this can be anything. Again, just because I work kind of with Databricks. So at Databricks, we have an offering called Databricks Apps, which is the exact kind of same thing as data apps. Basically, you write your code or whatever and look at that, Streamlit, Dash, and Gradio. Crazy. And then from there, you can deploy them onto kind of the cloud and instantly like question and talk with them. So here we have like RAG chat apps is a pretty big one, right? So being able to, if I build a RAG application or a RAG agent, that's going to be an LLM, large language model powered application that's able to query your database, whether it's documents or tables, and then kind of take your question, find a result, and synthesize that back to you. So it's a retrieval augmented generation chat application. But notice that, that's a data app, right? And you need to have specific rules in place to limit things like governance. If Brian's questioning this, I don't necessarily want Brian to see the health data of all my other customers. Or if James is querying it, he's an intern, and I don't want him to see the credit card numbers. You got to make sure you're interfacing with governance as well as you have trust in the outputs, right? And when you get into more of those complexities, you again see the limitations of where BI tools start failing, right? So in this class, our data apps, again, it's because this is like a fairly quick 10-week boot camp. The data apps that we're going to be building in this class are going to be fairly simplistic. And because of that, there's going to be a lot of overlap of them with what you could do in a BI tool. Like, sure, I could make a much prettier pie chart and a much prettier map using Power BI. So why the heck am I doing this in Dash? Great questions, right? But behind the scenes, just think about the larger purpose, right? What if I had a machine learning model or an agent or a chat application or governance layer on top of this? Or what if I wanted more complex transformations to happen behind the scenes, right? Now, with data applications, you get kind of more native integrations with ML and AI, and you get high flexibility because again, you're coding it from scratch, so you can design it however you want to, right? And then you also own the governance, and the primary users are typically going to be more data-driven personas, such as other data scientists, engineers, technical stakeholders, etc. While again, on the BI side, it's typically going to be business users with really limited technology skills that are going to be interfacing with them. So just think about the trade-offs there. Again, there's overlap in any dashboard that you make or any application that you make should be able to be easily consumed by the target audience or the target stakeholders. But the underlying purpose of when to use which tool will change. And again, there's many, like every organization I work with has some combination of a BI product as well as some open source like data applications, right? Cool. Yeah, so pretty common architecture pattern here. I like this. You have your OLAP, your warehouse, your data lakehouse. Your BI analyst just sits right on top of that. They connect directly to Redshift, Snowflake, Databricks, BigQuery, pull the data into their interface, drag and drop, create a pretty executive dashboard, hit publish, and then the CEO logs in every Monday morning and checks his sales from the last week. But then maybe we have APIs or agents or ML models that we need to be doing live inferencing. Like I said, just a quick, lightweight football lineup model, right? Now we can spin that up using Streamlit or Dash pretty easily, deploy it. Or maybe we want to build a quick RAG application to query, I don't know, cybersecurity documentation, spin that up as a data app, shove it through, deploy it. Again, your data apps are going to be a lot more lightweight ML data focused and consumed by a more technical audience versus BI tools, which are going to be way less overhead in terms of their maintenance and deployment as well as their consumption. Cool. Yeah, and like in my personal experience, I use both day to day pretty much. I used to be a Tableau Power user. Now I can fumble my way through both, and most of my day to day is spent in Streamlit Dash. Just because of my role right now, it's a lot more data focused, and a lot of the personas that I work with and organizations are a lot more like data engineering, data scientist focused. Yeah, great conversation, and that kind of leads straight into kind of what we want to get into with week six. Where the purpose of week six, right, was a deep dive into data visualization slash EDA, right, exploratory data analysis. So as I kind of going through some of the lecture and then jumping into the code, please be sure to kind of drop questions in chat just to give Karen something to do while we are here. And I'm actually going to give Karen the floor for 30 seconds while I grab my water bottle because I need to grab that real fast. So BRB. As the purpose of this week was to do a deep dive into different types of data visualizations that you run into, as well as how to start using Python libraries to create those visualizations and then design dashboards kind of off of that. But I also want you to think of a few different ways of these visualizations, right? So the first is going to be static versus dynamic or static versus interactive. Everything that we create using Matplotlib this week is a static visualization, right? It's a bar chart, it's a pie chart, it's a line chart, and you can save it off as a PNG or a JPEG, call it a day. With that comes a hot. Is that my sound? I don't know whose sound that is. Everyone's muted here. Oh, weird. Hold on. That was my sound. All right, we're back. Cool.
Yeah, it
I
looks
think we're
like everyone
focused here.
else is muted
Yeah, yeah.
except
No
now.
worries. Yeah, so I'll talk about static visualizations, which we're creating with Matplotlib, and then moving into this idea of the power that interactive and dynamic visualizations can give you. And again, we kind of demo that using Dash, but in the real world, we're going to be using BI tools to do that, like Tableau and Looker, etc. And then finally bringing it back to what is the purpose of Dash and this idea of data applications, the power of having Python be able to be your data engineering logic, your machine learning modeling logic, as well as an application logic. If that's all Python or Pythonic, then we can now really easily connect all of those different left to right pipelines together in kind of one unified ecosystem. Cool. So there wasn't too much to get into with the actual like week six like workflows. A lot of the labs are fairly straightforward. I'm kind of reviewing just the different types of visualizations in Matplotlib. So we'll do kind of one example of those first, and then I did want to do all of the 613 activities here. But yeah, let's just do a quick warm up. What's the one that probably matters the most? 6-6 maybe? 6-6 is gross though. 6-5 probably. Yeah, so let's just like run through a quick number of these. 6-2, review pre-processing with pandas. So again, that was the big idea for week 5, that data preparation. 6-3 goes into introduction. We'll start there actually as our warm up. 6-5 is also pretty good. 6-6 goes into pie charts, box plots, scatter plots, and bubble plots. And hopefully when we get to the end, you'll realize that a lot of these statistical charts can be better done using Seaborn. So again, this is a fine notebook, but look how ugly this box plot is. It's so ugly. I hate it. It's so gross. Um, yeah, so anyway, in the end, you'll eventually get to a Seaborn lecture, which is really good. And maybe 610, I think they do. This is my favorite notebook, but it's kind of irrelevant to the larger idea. But yeah, waffle charts, word clouds, and regression plots. But it does use Seaborn here at the end. And you'll see that with Seaborn, you can really quickly make your regression plot. I think I will also show. All right, we'll see. We'll tackle this by ear. We'll see where we go. So let's start with our warm up. Let's start with 6-2. So I'm gonna launch that and we'll do it live here. Yeah, Seaborn, if you haven't done or looked at the Kaggle data visualization mini lecture, it's really, really good. You'll see lots of like why we use Seaborn for statistical data visualizations. So again, contrast that to, I guess, what's the opposite of like statistical? Like more like reporting based, objective based. With data visualizations, they're either going to be, I guess, descriptive or prescriptive. I can't remember the other word for it. Statistical. For example, like making a line chart or making a bar chart, that's like one thing is like describing, kind of is telling a story. But then looking at correlation plots or histograms or distribution plots, those are going to be more informative for you as we start building out models off of this. So it looks like we're connected. Let's actually, oh, this is the pre-processing one. Let's do 6-3 as my introduction to Matplotlib. Yeah, the word cloud. I'm a big fan of word clouds just because I had like a natural language a decent chunk of natural language experience back in the day, and I think word clouds tell a very fun story. Anyway, let's do our quick introduction to Matplotlib here. So as we've talked about, Matplotlib is going to be the main framework for building visualizations inside of Python. And even Seaborn. Seaborn is behind the scenes running Matplotlib. And Matplotlib is actually integrated with Pandas, which is great as well. So we'll let this go through. Great. And let's grab our data set. So this is some immigration data from Canada. And again, we can look at what our data looks like and get the list of years we need for our graphs. Again, I think there's a good thread going on about date times, and yeah, plots and dates. It's all a mess. Again, I would recommend trying to keep your data types correct. So if you do have a datetime column, making sure that is actually the datetime data type will usually make your graphs a lot nicer. Yeah, there is the other one. You'll see like hard-coded formats and like creating like static visualizations. And what you'll see here too is like with Matplotlib, the very basic version of Matplotlib is like pretty ugly. So we want to usually apply styles, or we have the flexibility to like make our these graphs look however we want, right? That's kind of when you do have flexibility given to you with open source libraries, it can also be overwhelming, right? Just trying to figure out how to define it. So let's do a quick like hello world here. We're going to do a line plot. A line plot is useful for looking at change over time. Usually your x-axis is going to be a year, month, or a day, and we're going to be looking at kind of patterns over kind of a time frame. So here's this really cool thing, right? All I have to do is call Haiti.plot, like, but what the heck is this? What is happening kind of behind the scenes here? This is using the Pandas Matplotlib integration to create a chart. Notice that we have a data frame that has two columns in it, the year and the amount of immigration, and Matplotlib was automatically able to kind of plot that for us. Now we actually get into the real weeds of Matplotlib. With Matplotlib, there's a lot of things it can do. So usually I would say you need to have some kind of information, I guess description there. So typically every graph you're going to make is going to have a title, X label, and a Y label. And this is the command to do that through Matplotlib. I like to say too that like with the graphs that you make, you should be able to give it to someone that has zero context, zero technical ability, and they should still be able to visually identify the patterns in your data set. So again, looking at this, we can see that there's a huge spike in 2010. And again, like maybe without even knowing anything. Again, because I'll like compare the difference with this graph right here with zero titles and zero annotations and zero labels. This could literally be anything. But once we start adding that descriptions, we can actually make sense of what's going on here. And now there's a data story to be told. What happened in 2010 to have this huge surge of immigrants? Well, of course, you had the 2010 earthquake in Haiti, which could be a causative, I guess, relationship to why we had that huge spike. But notice that we quickly have annotations, we have color, we have labels, and all of it is helping to tell a story, right? I think back in week 1 or week 2, we talked about Tufte's data visualization principles. That still goes into effect here. You want to make sure that your colors are not clashing and your colors are telling that cohesive story. So my only note for this graph is the background grid color being this dark gray is kind of ugly and kind of is increasing the ink to data to ink ratio when it shouldn't be needed. So that's the biggest one that I would remember if I was you, data to ink ratio. Basically, this means that the amount of text or ink or like whatever you're drawing with should be at least related to the data, right? Or helping to tell your data story. So you see that like, yeah, this is a good graph. If I can open this one up on the right here. Open image in new tab. There we go. So the image on the left typically is going to be frowned upon, right? Like it's got all these extra like images and things that are kind of distracting. It's got different font. Is that chiller? Oh my God. It's got weird fonts going on. It's kind of a mess. But the same information can be told on the right as well. I would probably say that I would prefer having the x-axis here. I would do the x-axis with the labels. But notice that we're getting rid of these icons, which is the main one, right? And you'll also see that with the data to ink ratio, it typically minimizes a reliance on the background grid. So because of that, we can see that here we have an over investment in our background grid, which could probably be the first thing I would say to minimize. I'm not going to run through all the rest of these, but know that with Matplotlib, we're able to create many different types of visualizations, not just line charts, but also bar charts, histograms, box plots, area plots, pie charts, scatter charts, and even hex bin charts. And I think in one of my forum posts, I posted some quick notes about like when to use each type of graph, but maybe not. Maybe we can cover that today as well. Cool. So let's keep moving here. I want to show real one here. I think we'll start with 6.5. Yeah, I think we'll start with 6.5. So let's jump into 6.5, which is going to be the what I would say is a pretty solid uh, like use case for Matplotlib here. So there's going to be an introduction to a few other charts, some of the most popular ones that you'll see in the world. Not just line charts, but histograms to look at the distribution of kind of a single data feature, bar charts to look at relationships between categorical and numeric information, and then area plots, which I also don't use a lot, mostly also because of the data to ink ratio. But area plots typically also tell that story of change over time, just with some additional information provided. All right, so we're looking at the same data set, the Canada immigration data set. And here we go, making our plot. So you notice that when we create our plot here, we're doing the exact same thing. We have our title and our labels. We're also specifying things like the canvas size. Whenever you see a fig or a figure with Matplotlib, that typically is defined as the canvas that we're going to be doing our artistry on, right? Like before we paint, we got to have our canvas. And then we can also see some other parameters around the Matplotlib area plot. And to me, this is disgusting and really messy, and there's really no need for it. I would never do a not stacked area chart. I don't do area charts anyway, but notice that if I was to give this to your grandmother with zero context, she'd be like, yeah, I have no idea what's going on here. It's a really busy graph, a lot of extra ink being used that probably shouldn't be. Maybe there's too many countries that we're trying to compare at once, right? And maybe the transparency values aren't helping. But even when we clean it up, like this is still a really disgusting graph to me. I don't think this is helping much at all. So what I do like with area charts are called stacked area charts. And maybe we can actually do that in here. Maybe we just say true and see how ugly this looks. Oh, there we go. So this actually looks a lot better. I like it. Let's set our alpha back up. I'm gonna set my alpha to 0.8. Alpha is just the opacity level. And honestly, I don't like that much opacity in my graphs. So look at that. I already made a better graph than they did, just with a couple small tweaks. So kind of what we're showing here, there's a stacked area chart, which makes it a little bit easier to compare the change over time for these countries. And again, the reason why you use an area chart versus a line chart, let me actually make a line chart too, so we can compare. There we go. So it's kind of the same graph, but as a line chart. And again, this is also super funky and messy. And sure, it uses less ink, but the story it's telling can't be uh, connected. So like it's a lot more difficult to compare these countries' immigration. to each other. And this looks like when my toddler's scribbling on the wall with his crayons. Like it's literally the exact same art. But if we look at this one, we can actually start seeing some comparisons, right? This is again why I really like stacked area charts. If I'm looking at the UK, where's my pen? UK, we can see there was a huge influx here, kind of in the early 90s, especially compared to the later halves, right? China, we see a larger influx with China happening in the early 2000s compared to times before, right? We see Pakistan kind of increasing, right? Philippines increasing here at the end. So we can really start to compare countries to each other as well as countries to themselves, just with that, again, change over time aspect. So yeah, I would say that notice that we have categorical data being introduced here. The categories being the individual country. We still have the change over time with the line charts, but area charts, especially stacked, help relay that categorical relationship a little bit more. Cool. I want to keep running through this notebook, but I'm gonna have a hard out for myself in 5 minutes. Cool. So when we create plots with Matplotlib, there's a couple different ways. I would say there's actually three different ways that you can create a graph in Matplotlib, which is super annoying, but it is what it is. So the first is how I would typically do it. Where's my data set here? So the way that I would first do it is it's called, I don't even know, just the Matplotlib library or the Matplotlib API. Let me just look at my data set. DF top five. Cool. Oh, gross though. Whatever. Cool. So the way that I would do something like this using this vanilla Matplotlib, you do something like plit.figure, create your canvas. Then you would create your chart. So I'm just going to do a plit.line chart here. Uh, plit.line, but well, I guess I'll do plit.bar. And then you can do, I'm just going to do df.index, what is it, top five. And then let's say I want to plot India. Let's see if that even works. I don't even know how to code. Oh my God, it did work. Great. And then we can add in our like plit.title, India immigration. And then plit.x label, which is going to be our year. So notice how everything I'm doing is preceded by PLT, which is the Matplotlib PyPlot core library. So I would call this like vanilla, uh, like Matplotlib, right? Just straight up Matplotlib by itself, just how the library works, right? Declare your easel, canvas size, and then create all your stuff, add customization as needed, and you get this beautiful little graph. So that's part one of Matplotlib. To me, that's how I usually do it. It's pretty easy, straightforward. The third way, notice I'm skipping the second one for now. The third way is to integrate Matplotlib directly with pandas, which is what we've been doing before. So in this case above, right, we're using the Matplotlib integration, the plot function within pandas, to define the canvas and define the big idea of the plot. And then we customize it using the Matplotlib library, which is fine, I guess. But to me, when you do it fully within the Matplotlib library, it's more defined about what you're doing. It's a little bit easier to read, right? I'm making a bar chart with these data sets versus like I'm going to plot the entire data frame as a line. Like that's just a little bit more vague, I guess. But that's the third way, just use the pandas integration. And then finally, the second way gives you even more flexibility with Matplotlib. It introduces the concept of axes. So technically, in Matplotlib, when you create your canvas, right, I get my easel out, I put my sheet of paper on it. That is defined as my figure. But within a figure, I can have multiple subplots. I can have just one subplot, which means that's just my one graph on my easel. Or I could have multiple. I could have four subplots, for example, in which case I need to divide my canvas up into four equal spots. Those subplots are known as axes. So when we get to a graph that looks like this, which means create a single axis. This is essentially doing the canvas with one subplot, which to me and to you, you should be like, what's the point? If I have a canvas with one subplot, that's the same idea as if I'm just editing the canvas directly because it only contains one plot, right? And the answer to that is yeah, you're exactly right. So the reason why some people like to do, I guess, this scripting layer, I guess, is that with the axes, it's more defined. If you wanted to add a second graph, you totally could, right? Because we've already defined this idea of having multiple graphs on one canvas. So here what we're doing, we're creating a single canvas with a uh, single plot, and then we're editing that single plot itself. And again, the reason why I don't like this is because what do you mean? Why is the syntax changed? Why can't I just do ax.x label? Why do I have to do set x label? Like, what the heck? And again, yes, Matplotlib and its syntax sucks. It's crazy. Why do I have different syntax, whether I'm editing the overall canvas or whether I'm editing the individual graphs within the canvas? And to that answer, I don't have a good answer for you, but yeah, it sucks. I feel
Yeah,
like it.
and that's the confusing part, is to basically understand when do you use when or what, I mean, so
Yeah, for sure. And so again, from my perspective, is a majority of the time you're going to be creating just a single graph. In which case, if you're only going to be creating a single graph, just use the single default canvas. And it's only going to be in exotic situations where you do want to create a single graph with four images in it that you would then create the axes. But I would even do a little bit of a devil's advocate on this, being, what's the point? Why am I creating a graph with Matplotlib anyway? It's usually because of two reasons, right? The first is information for you as the data scientist, as the analyst who wants to look for patterns. In which case, doesn't matter if the graph is kind of ugly. No. So just create as many graphs as you want, keep them ugly, who cares? The second is I'm creating a static visualization for some kind of report. I want an image to put into a slide deck. I want an image to put into a white paper, etc. And if that's the case, then to me, what I would do if I want to create four graphs on one image, which let me pull up here. I think that was in 6.5, and then we'll move on to 6.13 here. If I want to create a single graph in one image, which if you get to the very bottom, I think you do. Maybe not here. Oh, because that's the histogram. Oh, maybe it was in 6.7. 6.7. Oh God. Um, Here we go. 6.7 goes directly into the kind of the comparisons between the idea of a canvas with a single image and then a canvas with multiple sub images. So here's kind of what that sub image looks like, right? I got four graphs in this one canvas. I got four axes. I have this line chart, this scatter plot, this bar chart, and this pie chart. And again, you can kind of see how I did it, right? I defined my canvas as having two graphs at the top and two on the bottom, right? And now I have axis one, axis two, axis three, and axis four. To me, that's the only reason to use that axis logic. And again, the point would be that I could then copy this directly into a slide deck or a white paper. Again, in my experience, just create four graphs and align them on your slide deck as however you want, right? And just call it a day. So. Yeah, that's why I wouldn't get too hung up on the syntax. Don't get too hung up in the logic, but stick with the big ideas. Matplotlib allows us to create static visualizations because of its ability to tie directly into pandas. We can create quick and dirty visualizations around our data sets that we can then use to help us with our hypotheses or reports or machine learning models or reporting, etc. The types of graphs you're going to make, if it's going to be looking at change over time, you're going to be looking at line charts, area charts. If you're going to be comparing categorical data with some numeric value, you're going to be using bar charts. If you're going to be looking at percent of whole, you're going to be looking at pie charts. And then if you're going to be looking for relationships between numeric variables, you'll be using a scatter plot. And then finally, we also introduced statistical charts such as box plots, violin plots, etc., waffle plots, I guess, that help understand. I guess not waffle plots would also be part of whole. But yeah, your histograms and box plots that let us understand the distribution of a single numeric feature. And I'll demo one of this in 613, I think. Yeah, because yeah, I'm a big fan. Violin plots are my favorite chart of all time. I think they're beautiful. Look at that. So just kind of what this graph is telling us, it's telling us so much already. So what this is, it's plotting the distribution of the data. So this is Titanic data. This is like people that were first class, second class, third class, and then their age and whether or not they survived. So looking at third class, for example, we can see that regardless of whether or not they survived, you kind of had this peak that kind of lines up with like early 20s. So, and we can see that this peak is less than the other ones, which again implies that younger people were in third class, which is great. But we also had some weird skew, like we did have some like 80-year-olds apparently in third class, which is kind of funky. Compare that to first class. We're on first class. We have some more interesting observations. First, that they tend to skew older, which again kind of makes sense. And then two, we have kind of a much wider distribution, as in that we do have some people of all ages in first class. And then what's interesting to me is we have older people that did not survive compared to younger people that did. So the people that survived in first class were on average younger than the people that didn't. Compare that to the other classes where everybody was pretty equally likely to not survive. But this implies again, like women and children first, especially women and children from first class first. Those women and children are going to be statistically younger on average than the rest of first class, which seems to be why the survivors of first class would survive more younger. So pretty interesting. And again, all that just from like a distribution chart. I love it. So being able to break down, that's kind of what box plots want to do, but box plots can't typically be as descriptive as you can by plotting the distribution itself. So it's kind of a fun little combination of box plots and distribution plots. So Seaborn is a library that gets introduced in week 6. It is all for statistical distributions. So it's a statistical plot. So its use is to help you as a data scientist understand the distribution and relationship between your features to help you build the best model or identify the best patterns possible. So there's some really, really cool graphs you can make with Seaborn, and by default, they all look really pretty compared to Matplotlib. Yeah, and hopefully what else you take away from Matplotlib, creating a box plot in Matplotlib is a huge pain in the butt. The way that the syntax is, it's really, especially if you want to do multiple box plots, it's a really pain in the butt. And so Seaborn kind of fixes that issue for you. And behind the scenes, it's still running on Matplotlib and integrates with pandas super easily. So pretty fun little library here. All right, we got 40 minutes. Let's dive into week 13. Or not week 13, week 6, activity 13. So we're going to start with 613.1. This is the capstone for the week 6. And we're going to be analyzing wildfire data in Australia. And hopefully, oh, there's my kernel. Perfect. All right, so let's get into it. We're going to make sure that we have Seaborn for our statistical visualizations, Folium for our maps, and we're going to be using Matplotlib for our general visualizations, and then pandas, NumPy, etc. And you can ignore any warnings about PyArrow and stuff. Cool, so let's go grab our data and take a look at it. And then remember what we said last time, the first thing we want to do is look at our .info just to make sure that we're able to pre-process our data correctly. So just a quick reminder of how pre-processing works. What are the things I'm looking for? I'm looking for 3 things. Null values, I'm looking for data types, and I'm looking for column names. So get your chat fingers ready. Do I have any missing values? Am I missing null? Do I have any null values in this data set? Thumbs up, thumbs down. Right. Yes, we have two columns with null values. The confidence, standard deviation and variance of our confidence. We're missing about 2,000 rows. Let's actually just do a quick thought idea with that. So we're missing about 2,200. We have 26,406. So that's not a lot. That's about what? Less than 1%, right? I think I did my math right. So we're not missing that many. So sure, like in a pinch, I would probably just drop those all the rows because it's not really that big of a deal. But notice if we wanted to, we could also impute them as needed. We're not going to do anything with null values in this example, but note that you probably should if you wanted to plot or use those columns in a statistical model. Next, let's look at data types. Data types, most of them look pretty good. Anything that's already a number should be pretty good. And then it looks like we have a couple of strings. Looking at our df.head, region is definitely a string. Replaced is definitely a string. But date is a date, so that should not be a string. So we need to fix the date data type. And then finally, the column names. I would probably put them all lowercase, but there's no spaces, there's no foreign characters. Column names are probably fine. So it looks like the biggest thing we have to do is fix the date data type. And that is why the next thing we do is convert it. And then not only can we convert it to a date time, but we can actually extract information from it. So notice we're creating two new columns, year and month. And just for completeness, here's how I would also do it. Let's add in a new column called dates, where I'm just going to convert date to a date time. So notice we have dates now as a date time, and we've done some feature engineering. Look at us. We've created two new columns from an existing column where we extracted the year and the month as new columns. So pretty cool. All right. So what we want to do now is we want to look at the average fire area over time, and we want to use the pandas plot method, right? Not just the Matplotlib syntax. So here's what I put together. We're going to define our canvas. We're going to group by year, and since we're going to be doing a change over time, I'm going to use a line chart to represent this. Notice that by default, plot creates a line chart, but I'm going to be explicit here and add in a kind equals line. So again, it's always good to know which graph to use for which purpose. And then here is kind of what this looks like. If I was actually doing this in the real world, I would say that this looks super ugly. And what I would probably do instead of a line chart, maybe let's do a bar chart and see how that looks. And so here's kind of what a bar chart looks. And to me, this actually tells a little bit more of a better story here. We can still see that peak in 2011, 2012, but we don't really get these jagged lines that don't really mean so much, right? And so maybe for a line chart, it would be better to have a more Ooh, are we going crazy? We're going crazy in the live coding today. For the line chart, I'd probably would group by more than just a year. Maybe we look at year and month. This is not going to work, but you never know. Oh my God, it kind of did work. So there we go. So now we kind of also see the seasonality patterns that like in the summer, you're going to have more spikes in terms of fire, not just by year. So that's pretty cool. And then with the line chart, you get that much more like continuous approach. If I also do the same thing as a bar chart, that's where we're comparing data visualization types. We'll see if this actually even works. It does. But yeah, look at this. This is disgusting. Now this is disgusting, right? We got the X labels are nuts. My like trends are nearly as noticeable, etc. So that's kind of the difference here that I'm thinking about as I'm making these graphs. We're looking at change over time. So we want to be using some kind of line format where there's meaning left to right. But with line charts, the more granular you get, whether it's year, month, or year, month, day, or even year, month, day, minute, you're typically going to have better visualization. So the trade-off I did was since we have a very static level here by just looking at year, this was actually looks better as a bar chart, but it won't actually hold true forever, right? Not every problem will be kind of related to that.
Yeah, the question I always have, Alexander, is if you go back to that line graph with the years, yeah, like that. The question always comes to my mind is it might still imply that, for example, 6 months into 2010, it's at that level that's between those
Right.
points. And so that interpolation may not be reliable or accurate.
Yeah, exactly. Cool. Um, let's to keep flying here. We'll just run through a couple more. Yeah, so here we go. This is where we start using year and month, and you notice with the line plot, this looks a lot cleaner. We already went over that. So now let's actually start using Seaborn to start develop some things. So there's really no reason to use Seaborn for a bar plot, but why not? So we can see here we have 7 categories for region. Whenever we're doing a categorical column and connecting that to a numeric feature, bar plots are typically the best way forward. Seaborn bar plots are good, but I'll show you the true power of what a Seaborn bar plot can do here, or what a Seaborn plot can do. Well, I wish we had a true or false column, but let's do one anyway. Let's do a violin plot, just because I like a good violin plot. I think this will actually just work. Violin plot. We should be able to get the same. Oh, look at that. That's beautiful. Whenever you're going to be looking at like a box plot or a distribution plot or anything, you can just typically do a violin plot instead. So kind of what this is showing me, this is again derived from each region. We're looking, again, it's kind of funny that we have really only need one side of the violin here because we're only looking at one part of the graph. But what we can quickly do is look for skew. So all these regions do have a right skew, right? We have some crazy kind of tips here. Specifically in the SA region that has a pretty long tail. Same with New South Wales has a long tail. But we can also compare the peaks, and we can see here that Tasmania, no, I don't know where I went. And Northern Territory, duh. NT shows my USA geography knowledge. NT here has like at the highest peak compared to a lot of these other ones. Notice that SA here has a larger, flatter distribution, so there's less of a peak. Um, and then what else? Whichever one, some of these have like the lower peaks here. So we can see those have less fire, even if their skews are long as well. Anyway, we're looking at distribution plots. Because it also goes back into like why we need a standard scaler and we do have skew. So how do we start scaling kind of our data? But yeah, so we can see this here, distribution of the mean. We can see these bars, but a plot like this kind of tells the story a little bit deeper. Just to finish this up, we're gonna fly through a couple more of these. Pie charts. Why am I using a pie chart here? We want to look at the a portion, part of whole of pixels of fires across regions. Because we want part of whole, we're gonna use a pie chart. Pie charts to me though are gross and disgusting. They're really easy to lie with. For example, if I did not have labels, would you know that the orange is bigger than the pink? Probably not. I have to be pretty explicit with that. This is why you're going to see donut plots used a lot more in industry these days. We touched on donut plots in the past, but because they eventually turn the pie chart into curved bars, it's a lot more aesthetic and functional version that's harder to lie with as a chart. So whenever you need to do percent of whole, That is typically what I would recommend. And again, yeah, here it's impossible to compare purple, orange, and purple to each other. So just again, things to keep in mind. If you don't have to use a pie chart, I wouldn't. And also for this problem, this would also just work as a bar chart. Like we don't have to be a true percent of whole here if we're just comparing estimates of fire by region. Back to the statistical plots. We can use a Matplotlib histogram here. And again, this is going to be very similar to our violin plot. Notice that we're looking at our distribution. So whenever you see a histogram, a box plot, violin plot, at the end of the day, they're all plotting just the same thing, which is a distribution. I can see we have right skew based on my long tail. I can see we have a pretty good, somewhat normal without, if we remove those outliers, kind of with a peak around 325 in terms of this mean estimated fire brightness. But also notice how ugly this looks. And Seaborn, if we're going to do anything with the statistical plot, we should just use Seaborn. And wow, Seaborn, so sexy. What a great plot. I love it. I'm loving these kind of larger lines and things like that. So again, long story short, if it's a statistical plot that's looking at distributions or correlations, you should probably just use Seaborn at the end of the day. Cool. So here we're going to do another histogram, and this is the true power of Seaborn. Compare the same histogram plot, but cross it across regions, or deviate it across regions. And this is a pretty disgusting plot that you can't really see or tell, but let's stack them on top of each other. Again, when we have multiple categories using stack, whether it's a stacked area or a stacked histogram, typically looks a bit better. To me, this also doesn't tell you much. It's pretty hard to compare everything, but it's a pretty graph at least, even if it's not very good in communication. Here's we're looking at a relationship between two numeric features, fire radiative power and mean confidence level. Relationship between numeric features means we need to use a scatter plot. Cool. And if you really, we're using a Seaborn scatter plot here. And if you really wanted to, you could probably, how do I insert code below? There we go. Use a reg plot if you wanted that regression plot. Hopefully that works. It didn't. But yeah, it did. There's a line there. You just can't really see it because there's not really any strong correlations here. There's a lot of noise, especially in the far end. So, last thing to do would be to create a map. Folium is, this is where I had some issues getting the background images to load on some of this too. Mostly this is just because of how Folium maps are sourced these days from OpenStreetMap. I may have to change the background image. What did I do on mine? I think I did a, what else did we do? Maps. If you change the background tiles, basically with OpenStreetMap, they made it so they need like you have to like cite your sources on them a lot more. But if you use a different tile, it should work. So if I'm going to use this CartoDB dark matter tile, let's see if that works. It still didn't work. I'm sure that was something we had to do last time too, Karen, to be able to get the maps to work. But either way, with the map, we get introduced some interactivity, and we should be able to see some descriptions between them all against each other. Notice with Folium maps, though, they only live within the notebook. So again, I would use it to take a screenshot of a specific section, which we have to do for the capstone, Karen, for SpaceX. So let's make sure that we're aligned with how Folium works in Jupyter Notebooks for that. But yeah, you still want to eventually get some kind of a static output. If I'm creating a graph within a Jupyter Notebook, the goal is for it to be exploratory for me, myself, and I, so a personal graph, or a static visualization for some report down the line. Cool. For the last 20 minutes, I did want to pop on over to Dash Apps. But was there any burning questions from anybody about Matplotlib, Seaborn, the different types of visualizations that are out there, when to use what type of visualization. Or I can also check the chat too. Cool. When to use one or the other. Seaborn, like I said, when I use Seaborn, Seaborn is typically for statistical visualizations. So what I mean by statistical visualizations are going to be things like scatter plots, distribution plots, right? Looking at the distributions of things. So with distributions, you have distribution plots, you have box plots, you have violin plots. They all show you distributions. Um, I like cat plots. Shows your kind of error. So whenever you do a bar chart, it shows you the error of the mean. So what's your confidence level in these averages? There's a statistic in the world called SEM, which is the standard error of the mean. So again, if you want to add things like confidence or standard errors to your visualizations, all of a sudden you're turning this from a bar chart into a statistical bar chart, a statistical visualization. And so again, that's what Seaborn excels at too, right? Adding in these statistical methods like uncertainty, even on the regression plots. It's super. We're looking to find the regression plots. Oh, it's a good thing it's alphabetical. Maybe residual plot, reg plot. Why am I just in the gallery? Yeah, with a regression plot, you can actually turn on the confidence. You'll see that we have this kind of shade of blue in the background, which gives us our error confidence in our predictions, which again is starting to add a statistical component to the graph. I'm no longer just drawing a line of best fit. I'm including statistics, including the error, right, or the confidence of my error of my residuals. So yeah, now we're turning this into a statistical visualization as opposed to just a communicative visualization, if you will, right? So that's typically where I use Seaborn. And then some of my favorite plots on Seaborn, we've talked about violin charts or violin plots. I love me a good violin plot. I also love a good pair plot. A pair plot gives you a scatter plot matrix. So remember we talked about in week 5 that one of the assumptions with linear regression is no multicollinearity. We want independent features. What a scatter plot matrix will do, it'll automatically generate a scatter plot of all of your numeric features. So sure, you can do df.core, look at the correlation of everything, but here I can actually plot it. So I can plot it to see if there are relationships between different features by themselves. And then again, the beauty with Seaborn is that it's really easy to break it out by category. So here we're breaking this out into my 3 species of penguins, and I can quickly see the relationships between everything. So again, there's a lot of information on this one graph. So let's just look at this one right here. We're looking at the bill depth versus bill length. And I can see there seems to be a positive relationship for all 3 of my species, even if that relationship is going to be pretty distinct, right? I'm going to have a different line of best fit depending on the species. So this also means that I probably need 3 linear models, one for each species, or if I do include one model with all of species, I probably need to introduce some nonlinear effects where species can be one-hot encoded using a dummy variable, and then I do a polynomial regression or something off of that. So we really get some pretty interesting observations here. But let's say that I want to conjure that to maybe this one, bill length versus body mass. This is pretty consistent. Like one line of good fit will probably be good for all of these, right? As the bigger the penguin is, the bigger their bill, I guess. But you have a lot of good information here, and you can see a lot of like multi-correlations between this. Maybe like an overall pattern that I'm looking at that's sticking out to me is that the green penguin, the Gen 2 penguin, they seem to be a lot more unique in all of these features compared to Adelie and Chinstrap. Here, to do, grab some pictures of penguins to put in the forums. All right, so let's dash on over to Dash. So I'm gonna open this up in 6.13.2 here. The Dash apps are going to be based, we're going to be creating Python files, not notebooks, and then we're going to be running the Python files as applications. So they're pretty cool. I already have the Dash app pre-made, but I want to go into how to run and create the Dash app, the purpose of it, and then what it looks like when it's deployed, and the information you can receive from it. The Dash apps aren't too complicated. On the code front, they walk you through everything you need to do for the code. So if you can actually like run to the end and then just copy paste the full Python script back out. Well, so here we are. Notice that the IDE should look similar to what you did in SQL in week 4, at least in the first half of the SQL labs. And so our goal here is to create a dashboard with that's interactive where I can add in a filter, and I want that filter to then change a pie chart and a bar chart. So now we get into this is literally what Power BI does, right? You can create a dashboard with a pie chart and a bar chart, add in a couple filters, and now you have a BI executive tool. So that's kind of what we're going to be doing here just to demonstrate that Python can do interactive dashboards. But again, the real power from this is let's say that James changes the drop down to pick a new region, New South Wales or whatever. That then goes into a machine learning model, generates a new prediction, and I get that new prediction served back out to this application. That would be tough to do in Power BI, but since everything is Python based with an application like this, it's almost just built in, right? Or maybe I want to do some more exotic data manipulation or pre-processing before it gets deployed. We can do that engineering kind of with Python as well. But yeah, we'll talk about that in a second. Let's kind of walk through. This is kind of hopefully what we look like. We want to have this drop-down region, drop-down year, and 2 visualizations off of it. Cool. So let's get our tool ready. This is what the IDE looks like on the right. To get a new terminal, I usually like operating out of this Explorer tab at the top. This allows me to create kind of new files and things within our project window. Let's generate our new terminal. And again, this is what I told you all last time. If you go Python, or not last time, I put this in the forum last night. If you go to Python 3 dash dash version, you're running Python 3.10. Does it make sense to use Python 3.8 or pip 3.8? No, not at all. So, and even if you check their screenshots, like literally look at this. Like I'm pointing at my monitor. The screenshot says Python 3 and then pip install packaging, right? So make sure to reflect that as opposed to these instructions. Again, it probably won't break if you do this, but in my opinion, if you're going to copy them over, but then get rid of the point 0.8. I use my keyboard arrows to move that. So there you go. Um, Same with this one. We'll just do all this as well, just so it's clear. Do not use Python 3.8. Use Python 3 to run everything. And some of these installations, Karen, if you're taking notes on some of the materials, like we don't need to install Dash twice. And also, like Pandas is already pre-installed, so I don't know why they're installing Pandas again. They're just updating it, but it's fine. None of the
Sometimes
scripts.
in like Linux implementations, you could sometimes have separate Python versions,
Yeah.
and 3.8 might still be there, and you'd end
Well,
up
I'm
using
like,
that at the
but even look
yeah.
at this. Python pip 3.8 and then pip 3. Like just be consistent. So to be consistent for the class, don't ever use 3.8. Just use Python 3, pip 3, and you'll be fine. All right, so we have all of our tools installed. We've reviewed kind of the error and the instructions in terms of installing the libraries. Time to create the application. Go to Explorer here at the top. We're going to hit this little icon to the new file icon to create our new file. Let's call it dash wildfire.py.
Well, can I just interject real quick though?
Whoops, it
If
should
by
be
chance, also by chance, you guys have any of you have set up this on Windows machine, your local machine on Windows, then you don't do Python 3, you just do Python. But if
yeah.
you're on Linux or if you're on Macintosh, you have to specify Python 3.
Yeah.
Also
There's
because
some
there's an installation often in those places for Python too as well.
Yeah, Mac has like a legacy installation of Python too, which is kind of crazy. But yeah, if you do ever install Python on your own computer, note that some of the terminology and syntax is going to be a little bit different depending on your operating system. Again, this is actually still running on Linux up here at the top. But so what I'm going to do here, I'm going to skip over all the actual exercises. I'll leave that as an exercise for the reader. But if you go to the end here, let's see if, oh, I didn't give you one. But for most of them, it does say like, here is the full code. Oh, here we go. Refer to the complete code. Thank you. I'm taking the shortcut. What do I want to call out in terms of the code itself? There's a few things I do want to call out. Again, don't get hung up on the syntax of Dash. Dash has its own, just like every other library, it has its own kind of syntax. But there's some things I want to call out here before we run the app. Cool. Good. So let me make this smaller and bring this up big screen. So the first thing I want to do with our Dash application, right? The purpose of having a data app is to have more control over your data pre-processing that's going into the application, integration with ML and AI, and then three, that additional flexibility in designing what the web page looks like. Especially when you talk about Dash, Streamlit, or Gradio. At the end of the day, they're all going to be creating websites, right? And Power BI and Tableau does this as well behind the scenes. They're going to be run on web-based technologies such as JavaScript and HTML. But with Dash, Streamlit, Gradio, it becomes a lot more specific. You'll actually see here that, hey, we're using HTML to create a div element, to create an H1, right? And so I've actually talked to some data scientists that are like, yeah, I hate Streamlit or Dash. Like, I just actually create a website. And I'm like, oh, ho, aren't you fancy being a full stack, full front end web engineer? And so, yeah, there's actually some like libraries out there like D3.js. This is a data visualization library completely built in JavaScript that's native to like websites. So if you are feeling like you do know your front end, you can definitely build out a data application that's HTML and JavaScript based that can still interface with Python in some capacity. But typically, we want to create shortcuts for this as, let's see if I can, you probably don't want to see an example of what here's an example of what a donut chart looks like in D3. Ooh, I love it. Look at those animations. I love it. Again, you have a filter and it changes. But if you want to look at the code, like, oh my God, like what does this even mean? Like again, it's its own syntax and stuff. But again, don't think about that. What I want you to think about is different ways to solve the same problem, which is I want to have an application that's powered for data technology users that can have flexibility and open source and customizations to meet me wherever I am, especially in terms of data preprocessing and machine learning. Anyway, to go back to our Dash app, notice again, similar things. I'm creating a website. I'm having full control of how that website looks like with titles, CSS, and other HTML elements. So even this radio item, right? This is going to be creating an HTML dropdown or HTML button behind the scene. And then this is creating an HTML dropdown kind of behind the scenes. But again, the beauty is we're connecting this directly back into Python. All I have to do is grab the unique years in my data frame, and now my data frame is perfect, right? Or what's interesting is let's say that my first command, instead of reading this from a CSV, I'm reading it from a database. Whoa, SQL. Now let's say that I have an ETL pipeline that's updating this Fire database every single year. Because I'm dynamically selecting the years from my data frame, as soon as it hits January 1st, 2026, that new record is in my database. It gets automatically select starred into my pandas data frame, and then from there it gets automatically updated to the app. So similar thing with Power BI and Tableau as well. But let's just say that I had more complex transformations that I wanted to do. Again, in Python, I can do those conversions. I can do other kind of advanced data transformations. In Tableau and Power BI, it's a lot more difficult to do that data pre-processing. In my industry, we recommend that you create your data as a gold or reporting level structure before you send it to BI tools. But data apps can live a level dirtier than that. You can have a what we call a silver layer, which is data that may not be fully ready for BI tools, but it's still good enough that you can transform it inside of the application layer to make sure that it can do the work that you need it to do. So anyway, we've talked about how we're structuring the website using Dash. It's still going to be HTML behind the scenes. We're now creating interactivity. That's what this application.callback means. Basically, whenever you change the input, here we have two inputs that we call these event listeners in the space. We're listening for an event. We're listening for an input, and then we do a callback. We call back to some function for some output. So we listen for an event, which triggers a callback function, which then provides an output. So here's how I would read it. We're listening for an input to change or to happen on region and year. That is then going to trigger this callback, which is then going to produce the outputs for plot one and plot two. And the function that this callback is going to hit is going to be this guy right here, this regreg year display. What we're going to do is we're going to grab the input year and the input region. We're going to filter our data frame off of those things. We're going to transform it by creating a averages, and then we're going to create my plotly graphs, a plotly pie chart and a plotly bar chart. And then we're returning those two outputs. And that's how that ties back in. And again, the only thing to call out here is notice how we're still doing Python-based transformations, right? We're still doing our like group bys and we're still doing our filterings and stuff like that. So again, you could still do that in like a Tableau type thing, but it's a little bit more difficult. And again, there's also no reason why. You're going to notice how flexible Python is. This function could say, take my input region, input year, read in a machine learning model, use these inputs to predict the fire area impact given those inputs, and then let's return back to the user that machine learning prediction, right? Or maybe this could be an agent, a large language model. The input is going to be a text query, a natural language query from my user, which then the callback function, all it does is sends that off to Gemini that's built on top of my database, and I return back the results of that large language model, right? Or maybe I can apply governance and masking and filtering in place. That's kind of the beauty of some of this stuff. If you're defining what happens within your application, you have full flexibility to do whatever you want. And especially with data ML AI, that flexibility provides a lot of benefits. All right, so let's go ahead and run this. Notice to run the application, we don't do it necessarily within the UI itself. Instead, we're going to do it within the terminal. So we're going to launch the application by running Python 3 and then the name of my Python file dash wildfire.py. Essentially, what this is doing is running the website, right? So if you're curious how websites work, you have a front end and a back end server. This is running as a Flask app, as a back end server, and then hosting the Dash front end for us. So here's where it's running. Let's go launch this. If I go back to this toolbox icon down here, we're going to launch application. We're running 8050 is our port number. I'm looking at this guy right there. And we can either load it inside of the, I guess, UI, but my preference would always be to open this up in a new tab. So here we go to a new tab. And here is our beautiful dashboard. Look at that. It actually works. So we can create, choose new buttons, choose new years, and you can see that that triggers a callback function, which regenerates the plot for my pie chart and my bar chart. And we can even filter this down, like I'm excluding some slices in my pie and stuff, automatically registering that, clicking between all of my different things, have a search bar, all that good stuff. So very cool. Then we can download these graphs. We can take a screenshot. And then how I see this working in the real world too is you can share some of these lightweight data apps with your technology consumers, explain to them how to use it, and then they can quickly kind of pull information from it. And notice that the real power for this isn't that just we create an interactive dashboard that you could do in 2 seconds in Power BI, but think about the flexibility of where this could go, right? Especially if we're doing machine learning, if we're doing agentic integrations, if we're doing complicated data transformations or joins in the back end, right? Like even on Tableau or Power BI, like if I have a SQL statement that's going across multiple tables and doing multiple aggregations, all of a sudden I've really slowed down my dashboard, right? Because it's executing that really large store procedure kind of behind the scenes to even power my information. Python's a lot faster. So if I'm doing anything kind of on the Python server side, it's going to be a lot faster than necessarily the SQL server side of things. So you get speed, you get flexibility, you get better integration with ML, AI, and agentic LLMs, and you can definitely power data intense systems a lot faster. Cool. So we've run through all of the Australian kind of fire examples here. Let me actually reopen that tab. I'll download all this. Any big questions from Dash? Again, like don't get focused on the syntax, don't get focused on the technology. What I do want you to focus on is this idea of data apps itself. So look at Streamlit, look at Gradio, look at Dash. They all do the same thing. Try and understand the larger ecosystem of where data applications fit in conjunction with the traditional BI tools. And again, just enjoy kind of the flexibility that coding visualizations can give you, especially when you can think about how, with practice, it'll become quick, repetitive, and you'll be able to understand the story put in front of you a lot faster. Like, I was able to read those violin plots because I've done it like a million times over the last decade and a half, right? So as you get more experience reading these graphs and using these graphs, you'll see the different ways that communication can be communicated. My last thought for you here is I always think about the target audience of your visualizations. If you're going to be making a visualization for you, you know your style, you know how you digest information. But if you're creating visualizations for external consumers, always prioritize them. And I usually ask them like what they want to see, how they view things. Like we go through multiple iterations of dashboard design. We think about Tufte's design principles, but also with my user themselves. Like what is going to be best for them to digest information. Make it a collaborative experience. Data scientists, you always work as a team. So I've also worked with front-end developers where they do the D3 JS coding, and I just help them say that I want a bar chart and a pie chart and a sunburst plot or whatever. But just again, think about that as a whole, right? Don't be selfish with your approach to visualization. Any last thoughts or questions? Actually, I think I maybe ought to stick around a few minutes late just to do the quiz, but that's definitely
Um,
the meat of my lecture here.
yeah, just one comment what I've picked up, I think it is somewhere in one of the activities is when you want to add a data value, or to say, for example, to a bar chart, then there's no quick solution just to, there's no parameter. You can just specify like legend or plt dot legend. You basically have to write a for loop to basically bring that in uh, to display your data values, which was for me was a bit disappointed in that.
Would say that it's still very dependent on the underlying kind of data set. I do think that
Mm.
depend and on how you've modeled the code as well. Like there's ways to make the code dynamic to be able to uh, like respond to those live updates like a lot faster than having to do a for loop. But yeah, that's a good comment for sure. Let me just double check I don't have a call right now. I would do have a call, so we'll keep this quick. I'm calling to go through the quiz real fast. Who created Matplotlib? I have no idea. I should ask y'all if I've already taken this. John D. Hunter. There we go. Oh man, passed away young. R.I.P. John Hunter. Using the inline backend, at what point can you not modify a figure? After it is rendered would be my guess. Which code starts the command? I guess matplotlib inline is probably what they want, but technically C and D are also valid here. What does a line plot display? Change over time. I guess information is a series of data points connected by straight lines. It's dumb. Which of the following is not the main layer of matplotlib? I guess histogram. That's just like a result in Matplotlib. What is a Jupyter notebook? That's a wild question to ask in week 6. Uh, I guess B. Select the function of Matplotlib is what do you think here? Visualization, graphing, chart creation, data. These are all just so dumb. Let's
Visualization, I think.
So dumb. All of these are correct. Select the option that best describes the 3 built interface classes. Figure, renderer, canvas would be my guess. Purpose of line plots already did this. Data over time. Display data and trends over time. These are all the same as well. Capture trends and changes over time. I don't know.
What was the question again?
Question 9. I have to jump to
What's
a
the
call here,
purpose
so we
of
got to be
class?
quick. That is not ideal for categories over groups, scatter plots.
Well, not all
Okay.
plots are going to be over time, though.
You know,
It's, I mean, it's
for
something
line
over time.
charts. Oh, 5 main dimensions. I guess box plot I was looking for. Similarly called by HTML. I guess it could be dash though. All right. Core plus map. Yeah. 2 parameters. You need the input and output. Plotly graph. Sure, that could be true. Waffles represent categorical data. Map style is OpenStreetMap. I think I passed. I think I got a 70. 72. That's my guess. 75. Let's go, boys. We
Yeah,
passed.
Alexander, if you can't pass it, I don't know what we're going to do here.
Hey, I passed it. So there we go. It's just whether or not like how wrong I was on things. I thought it gives you the answers of which are wrong or not. Maybe I got to change my
Yeah,
viewing of it.
yeah.
Uh,
It doesn't
but
for
yeah,
me either. I think for reviewing it would show.
yeah. All right, I gotta hop to another call, but this has been fun. I will see you all next Monday. Reach out on the forums if you need anything. And then I don't travel this week, so it should be a normal week in terms of updates to the forums. I traveled Tuesday to Friday again last week, so that's why I was so in and out of stuff. But I will see you all online as we go through. And again, yeah, thanks for spending the time and being putting your time into all of this material as well.
All right. Thank you.
All
Bye-bye.
right, yep, thanks all.